Hi, it's Mrs. Golding, and we're going to talk about angles. These are things that we've been talking about this week, but if you need a refresher, I'm going to do a quick refresher, and then I'm going to go over some problems that are in your Delta Math assignment, so it should help you. Okay, so these are the terms that we've been working with: adjacent angles, vertical angles, complementary and supplementary angles. So just a quick review. Adjacent angles, they share a side and they share a vertex. Okay, so they're right next to each other like that. So angle 1 and angle 2 are adjacent to each other. Okay, vertical angles occur when two lines intersect. Okay, so this line and this line intersect. And when that happens, we create pairs of vertical angles. So angle 1 will be congruent to angle 2 because they are vertical angles. All right, because those two lines intersect, creating that. So remember, this symbol right here means they are congruent, and congruent simply means they are the same size, same shape. Okay, they are equal in a way. So in this example, angle 3 is congruent to angle 4 because they are vertical angles. All right. So going back down here to complementary angles, I think in class I showed you how you can turn that C into a 9 and you make the number 90. So complementary angles are two angles whose sum is 90 degrees or a right angle. Okay, so the measure, if I can write this correctly, the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Okay, because they are complementary. Okay, so supplementary angles, I think I showed you that you can turn this S into an 8 and that U into a 0 and you get a 180. So in this case, a straight line is half of a circle, right? So here, it looks more like an egg, sorry. So half a circle is 180 degrees, right? So a straight line, anytime you have two angles that come together and make a straight line, or two angles who the sum of their measure is 180 degrees, I should say, they are supplementary. So the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. They are supplementary. So you have to know these definitions in order to do the assignment that we are working on this week. Okay, so you have to know these. Screenshot it, do whatever you have to do. Let's go to the next slide. So this comes directly from Delta Math. And so we're going to start. This is kind of like level 1. These two angles, A and then the one that's marked 59 degrees, create a right angle. And you know that because of this little box, right? And right angles are complementary. They add up to be 90 degrees. So we know that we're working with 90 degrees. And we have this missing part right here, which is angle A. So in order to find that, we're just going to take 90 and subtract 59. In your Delta Math, there's a calculator. I don't mind if you use that, right? But arithmetic is not bad for anyone. So we know that 31 degrees is the measure of angle A. Submit, boom, got it correct. Okay, so far I think you guys are getting that part pretty well. Let's go to the next one. So we're going to go back to our definitions, all right? And so we can see, and I used a Post-it note in class to help you to block things out. It's hard to do on a computer. I don't think this will let me. Let's see, try this. I don't know if it'll let me maneuver this very well. Cancel. If I can move this, I don't know if I can turn it. Oh, wait. Looks like I can. Turn it, turn it, turn it, move it. I could expand it. Sorry, I know this is taking too much time. Let's go. Okay, so this is kind of what I did in class. So I showed you how you can use a Post-it note to cover up parts of the image so that you can figure out what it's asking. It's hard to do on a computer, but let me show it to you. So we know that this angle here, 83 degrees, and C, make a half circle that's 180 degrees. So in order to find C, we take 180 and we take away that 83. So it's like I've got a phone call coming in. Let me pause this. Okay. So again, subtract. So 8, 10 minus 3 is 7. 7, 8 is at 97. 8 plus 9 is 17. So the measure of angle C, let me move this out of the way. Maybe not. Let's see, undo that line, grab the arrow. Measure of angle C was 97. 97 degrees. Okay, so then the measure, so this is 97. So the one that's left is B. And so you could do this all over again. And you could say, oh, okay, so now I'm going to cover up this line. I'm going to kind of this is a long way about doing this. Okay, so I can cover this. Oh, okay. So this one, 83, and B are half circle. They add up to 180. I could do my math again. That's silly, right? We don't have to do all that. We know that that's also going to be 97. And the other thing, if I move this out of the way, if you use your definition for a vertical angle, you'll remember that these two angles, so C here and B here, they're right across from each other, right? They are vertical from each other, so they are congruent. So angle C is congruent to angle B, and therefore they are the same. Okay, let's go to the next one. Okay, so then I think this is still found in the level 2, but it's definitely more difficult. So for this problem, you can use that Post-it note. You can try to block things off, but I've been telling students, just think of it like a puzzle. Find one piece of the puzzle, then another, then another. And you can start anywhere. I'm going to start with E. It's at the top. Why not? So angle E is congruent to this angle right here. I'm just going to call it X. And therefore, they are equal, right? They're congruent. They're the same. So angle E is 103 degrees, right? They are vertical angles, So the next thing I'm going to then do is I'm going to look at angle F. And I see that this makes a straight line right here. See how that's half a circle? So E, the measure of angle E plus the measure of angle F is equal to 180 degrees. And the measure of angle E is 103 plus the measure of angle F is equal to 180 degrees. Okay, so to find this missing angle, we're just going to subtract 103 from 180. So again, 180 minus 103. Calculate however you want to do this. 10 minus 3 is 77, right? So the measure of angle F is 77 degrees. Okay, so 77. And then finally down here, angle D, all right here. If I have angle D, which is adjacent to this angle right here, and you can see this line. This makes a half circle. This is 90. 90 and 90 is 180. Therefore, the measure of angle D must also be 90 degrees. Okay, let's go to the next one. Okay, solve for the value of y. This is the level 3. So this is the third assignment in Delta Math. This is where a lot of you are struggling. But once I show you, it's not terrible. So you have to have your geometry hat on and your algebra hat on. Okay, so you're doing two things at once here, which is really, really good for your brain. So this is a complementary these are complementary angles, right? Because they make a right angle and they're adjacent complementary angles. And so because of that definition, we know that the measure of this angle right here plus the measure of this angle right here are equal to 90 degrees. Okay, well, we're going to use that to our advantage, but we've got to use a little bit of algebra. So we're going to write this out, 8y minus 8. That's the expression that is defining the measure of that angle. So that plus 66 is equal to 90. Okay, so we're going to just take advantage of what we know about solving equations. So now put your solving equations hat on and go back, okay, what can I do? And for a lot of you, once you draw this line, it seems to help a lot. Remember, when you are looking at these, first think about what can I combine? Can I simplify this expression over here? Can I combine like terms? So I have two constants. So I have negative 8 plus 66. So really that's like 66 minus 8, right? So 5, 16 minus 8 is 8, 58. And that's a positive, right? Okay, so let's go ahead and write that as 8y plus 58 equals 90. And then we're going to say, I need to isolate my variable. So let's find the additive inverse of 58. That's negative 58, right? We're kind of stripping things away from this expression so we can isolate that variable. Well, we're going to do the same thing here. That's how we remain equal, right? That's equality. All right, so then additive inverses become 0. And so we are left with 8y is equal to 90 minus 58. Let's see, that's an 8, that's a 10. 10 minus 8 is 2, 5, 6, 7, 8. Okay, my last step, I have 8 times y is 32. So let's divide by 8. That creates a 1. 8 over 8 is 1. 1 times y. The identity property of multiplication says 1 times anything is itself. So y is equal to 32 divided by 8, which is 4. Okay, so right over here, 4. 4 is, we're not going to use degrees, okay, because you're just identifying what that y is equal to in that expression, and that's 4. So let's see if it makes sense. 8 times 4 is 32, and 32 minus 8 is 24. Let's see, so we're saying that this is 24. If that's true, then 24 plus 66, and these are both degrees, should be equal to 90, right? We're good. We're good to go. Beautiful. Okay, let's go to the next slide. All right, so this one we have a couple weird things. Looks like a big letter K, doesn't it? All right, so we have this 90-degree angle that is right here. We have 40-degree angle here, and then we have this angle, which is represented by that expression. All three of those angles together create this straight line. So when I have all three of those angles together creating a straight line, I know that their sum is 180. Well, I also know that this is 90, right? And we really don't need it, so we're going to kind of cast it off to the side. So we're getting rid of, and we're thinking about casting off that 90 degrees, right? We're not even going to consider it right now. So we know what's left. If we started out with 180, then we took away 90. So we have 180 minus 90. We're left with 90 degrees, right? So what that's saying is this expression plus this has to be equal to that 90. So let's go ahead and set it up. 7k plus 8 plus 40 is equal to 90. Okay, draw your line. That helps you know what's going to happen next. So now let's simplify this expression on the left. We have a constant of a positive 8 and a positive 40, and I can combine those. They are like terms. 7k is not. 7k and positive 8 plus 40 is a positive 48 is equal to 90. Okay, so let's work to isolate that variable k in that expression. So we're going to find the additive inverse of 48, which is negative 48. Okay, additive inverses become 0. And then we have 7k is equal to, be careful here, it's a minus. So 90 minus 48. 10 minus 8 is 2. 8 minus 4 is 4. It's a positive, right? All right. Last step. 7 times k is 42. 7 times what is 42? Well, let's go ahead and show it. I think you probably already know this. We're going to divide both sides by 7, and 7 over 7 is 1. 1 times k is k because of the multiplicative identity property. So k is equal to 6. All right, k is equal to 6. It's not 6 degrees, it's just 6. So let's check it out. 7 times 6 is 42 plus 8. 43, 44, 45, 46, 47, 48, 49, 50. So we're saying this is 50 degrees, this is 90 degrees, and this is 40 degrees. Do those all add up to 180? Yes, they do, to make this nice straight line right here. Okay, and it stands for a K, and that's O-K by me. Oh, and then put a G. Those are my initials, O-K-G. Okay, let's go to the last one. We now have vertical angles, right? So these two intersecting lines are here, and we have this angle and this angle. They are vertically from each other. So we know that vertical angles, if this was A and this is B, we know that the measure of angle A is congruent to the measure of angle B. All right, so we're going to now put that in terms of algebra. So we're going to say, well, what is the measure of angle A? We don't know, but we have an expression that defines it. So 7r minus 5 must be equal to 6r plus 4. That's the expression that defines this angle right here. And since they're vertical from each other, they are equal. So now we have this algebraic equation. Okay, so we've got that going on. Let's see. Okay, so first off, ask yourself, can I combine like terms on the same side? Okay, this expression has no like terms. This expression has no like terms. So now I'm to the point where I have to think about inverse operations. Okay, so what, and this is where you get choices. Some people like to start with their variable terms. Some people always start with their constants. Some people change their mind. And so I'm just going to go ahead and start with the way that I've seen a lot of you doing this. I think it's because that is how we operate with the two-step equations. And so it's fine. Just don't become inflexible. Like, hey, I could have subtracted 6r, right? Okay, just be flexible. Let's just do like this because that's how I've seen a lot of you do. So again, here, so the additive inverse of a negative 5 is a positive 5. Additive inverses make 0. 7r has not been dealt with, so we're going to bring that down here, is equal to 6r, and then I have 4 plus 5, which is a positive 9. Okay, so now let's deal with this term here, 6r, and this term here, 7r. So we have, we need to combine them, but in order to do so, we need to use inverse operations. So a positive 6r right here, which is what that is, the additive inverse is a negative 6r. I think it's hard to see that sometimes. People confuse it when it's a leading coefficient like that. So boom, we're going to do the same thing here. Minus 6r. Notice I use the word minus and negative simultaneously, exchangeably, interchangeably. That's what I was trying to say. So these are additive inverses. They create 0. So 7r minus 6r, those are like terms. We have 1r. There's one of them. 1r is equal to 9. That's what's left, right? 9. So let's check it. Okay. So let's substitute a 9 into this angle right here. So 6 times 9 is 54 plus 4. 54, 55, 56, 57, 58. So we're saying this is 58 degrees. Well, let's try. We're going to put that same 9 up in here for R. So 7 times 9. What is 7 times 9? Do you remember? 9 times 6 is 54. 55, 56, 57, 58, 59, 60, 61, 62, 63. I was just demonstrating in case you forget those, right? So 63 minus 5, 63, 62, 61, 60, 59, 58. So again, when we check those, they become, they are the same, right? And that's what we wanted. We wanted these to be the same because they are vertical angles. Okay. All right. Hopefully that helps you guys with this assignment and understanding angles. Have a great day.